So these last two examples, we're supposed to write the formulas for these. We just went over the general formula for a function for a geometric sequence, which was g sub n is g sub 1 times r to the n minus 1. I said that the way I actually don't like to say it. I prefer to think of this as any term of the sequence is the first term of the sequence times the constant ratio to the n minus 1. I really don't like to think of it as such abstract ways, saying g sub 1. Call it what it is. It's the first term. That's r. Call it what it is, the constant ratio. So for both of these problems, we just have to identify the first term and the constant ratio, and we can write the formula. So let's get started. This sequence right here, g sub n or a sub n or whatever variables you want to use, g sub n is the first term, 200, times the constant ratio. So the constant ratio is how we go from one term to the next. Now I know a lot of you are saying to get from 200 to 100, I divide by 2. You're correct. And to get from 100 to 50, yes, you are dividing by 2. But a constant ratio is what you multiply by to get from one term to the next. And constant ratios are found by taking any term and dividing by its previous term. So we could use 50 and divide by its previous term, 100. 50 divided by 100 is 1/2. So our constant ratio is 1/2. So first term times the constant ratio to the n minus 1. There it is. That's the formula. That's all there is to it. These can be expressed using function notation, like I showed you in the previous section on arithmetic sequences. Instead of writing at g sub n, we could write f of x. F of x is 200 times 1/2. Instead of writing n minus 1, we would write x minus 1. We could also, like I said earlier, if you wanted to use some different variables, you could say, I want to call this d sub b. Because you like the variables d and b. Go ahead, use it. There's nothing wrong with it. This would just be 200 times 1/2. Now your input is b, so you would say b minus 1. So any way you slice it, it works. The textbook is going to call this a sub n equals. There's nothing wrong with that. Alright, so for this next one, same deal. We need the first term, we need the constant ratio. We can see the first term, so I'm not worried about that. How do we get from one term to the next? You can probably tell from 4 to 12 you're multiplying by 3, 12 to 16, or 12 to 36 you're multiplying by 3. So you've identified your constant ratio is 3. So to write the formula for this, g sub n is our first term, 4, times our constant ratio, 3, to the n minus 1. That's all there is to it. If you want to check it, we could maybe check to see, can we get that one? This one is the third term, n equals 3. So if we find g sub 3, that tells us our n is 3. So we put 3 in for n. 3 minus 1 is 2. So we're going to have 4 times 3 to the 2. 3 to the 2 is 9. 9 times 4, 36. Verified.